Microphone. Think of the integrated microphone as the acoustic radar of a mobile device. In the early days of computing, a microphone was a bulky external accessory you plugged in only when you wanted to record something. Today, it is an always listening sensor critical for virtual meetings, voice assistants, and even biometric security. For the CompTIA A+ exam, you must understand that the microphone in a modern laptop or smartphone is a marvel of microscopic engineering. As a technician, you need to know how these tiny sensors process audio, how they work together to eliminate background noise, and how to troubleshoot them when a user sounds like they are talking from the bottom of the ocean. Part 1: MEMS Technology, the microscopic mic. If you picture a microphone, you probably imagine a traditional dynamic mic with a large magnet, a copper coil, and a vibrating diaphragm. That technology is far too large to fit inside a laptop lid that is only millimeters thick. Modern mobile devices use MEMS microphones. This stands for microelectromechanical systems. The hardware? A MEMS microphone is not a traditional electronic component. It is literally a microscopic mechanical machine etched directly into a piece of silicon, just like a computer chip. The placement: because they are so incredibly tiny, manufacturers can place them almost anywhere. On a smartphone, you will typically find one at the very bottom for phone calls and one near the rear camera for recording video. On a laptop, they are almost universally placed at the top of the display bezel, sitting on the exact same internal circuit board as the webcam. Part 2: the microphone array, noise cancellation. This is a critical concept for the A+ exam. When you look at the top of a laptop screen, you will rarely see just one tiny hole for the microphone. You will almost always see two or more. This is called a microphone array. Why do we need multiple microphones? The answer is active noise cancellation. The primary mic: one microphone is aimed directly at the user to capture their voice. The secondary mic: the second microphone is positioned to listen to the room, the hum of the air conditioner, the clatter of a coffee shop, or the whir of the laptop's own cooling fans. The processing: the laptop's audio processor takes the sound from the secondary microphone, mathematically inverts the audio wave, and mixes it with the primary microphone. This effectively cancels out the background noise, ensuring that the person on the other end of the Zoom call only hears the user's voice. Part 3: connectivity and the audio codec. Just like the webcam it shares a circuit board with, the microphone array needs a way to send its data down to the motherboard. The shared ribbon cable: the audio data travels down the exact same internal USB ribbon cable that the camera uses. It passes through the mechanical hinges of the laptop. The audio codec, a DC. Before the computer can understand the sound, the analog audio waves must be converted into digital data. This is handled by an analog-to-digital converter, a DC, which is part of the laptop's dedicated audio codec chip. If this chip fails, the laptop will not be able to process input from the internal microphones or the external headphone jack. Part 4: troubleshooting audio input. When a user submits a ticket stating, "Nobody can hear me," you must isolate the problem by checking the physical, logical, and software layers. 1. The physical layer: blockages and damage. Because MEMS microphones rely on sound waves entering a pinhole in the chassis, they are highly susceptible to physical blockages. Smartphones: the bottom microphone hole is notorious for getting clogged with pocket lint or makeup. A technician will often use a soft bristled brush or compressed air from a safe distance to clear the opening. Laptops: users sometimes put a piece of tape or a sticky note over their webcam for privacy, accidentally covering the microphone pinholes located right next to the lens, completely muffling their voice. 2. The hardware layer, the hinge pinch. If the microphone and the webcam both fail at the exact same time, you almost certainly have a hardware failure. Because they share the same USB ribbon cable, A pinched or severed wire inside the laptop's hinge will knock out both components simultaneously. 3. The software layer, privacy settings. Just like the camera, modern operating systems enforce strict privacy controls on microphones to prevent eavesdropping malware. The fix: if the hardware is intact but the microphone won't register sound, navigate to the OS privacy settings and ensure microphone access is granted to the specific application the user is trying to run. 4. The logical layer, default devices. If a user has a Bluetooth headset paired to their laptop, or if their laptop is plugged into a docking station with its own microphone, the operating system GHT be listening to the wrong device. Always check the sound control panel to ensure the internal microphone array is selected as the default recording device. Summary for the professional technician. To wrap up your understanding of mobile audio input. Technology. Mobile devices use microscopic silicon MEMS microphones. The array. Laptops use multiple microphones simultaneously to achieve active noise cancellation. Placement. They are typically housed in the display bezel, sharing a module and a routing cable with the webcam. Troubleshooting. Always check for physical blockages, like tape or lint, OS privacy permissions, and correct default device settings before assuming the hardware has failed.